answering questions. So if you guys want to take out your assignments, we'll start with some questions. Let's kind of go do a couple from worksheet 1, and then we'll go to worksheet 2, and then worksheet 4, kind of in that order. Gracie? Uh-huh. Okay. So here we're told that tangent of theta is equal to negative root 3, and we want to find an answer between 0 and pi. So the first thing I'm going to do is identify what quadrants tangent can be negative. So tangent can be negative in quadrant 2 or quadrant 4. I need a place where either the x is negative but not the y, or where the y is negative but not the x. And 0 to pi is quadrants 1 and quadrants 2. So the place that I'm looking for is quadrant 2. That's the location that I need. Is that okay so far, Gracie? Okay. So I remember that tangent is y over x. So I'm looking, and we're in quadrant 2, so I know the x part is negative. So I'm looking for something that looks like this, right? Now, but if I go and look at my unit circle, there's no place that has the x coordinate of negative 1 and the y coordinate of root 3. But there is some place that's close to that. I notice here I have the x coordinate is negative 1/2, and the y coordinate is positive root 3 over 2. Since both of them are over 2, that's not a problem for me, because when I do y over x, the denominator just kind of cancels out. So this is the location that I want, is 2 pi over 3. And I'm all done. Questions on anything that I did there? Is that okay? I'm sorry, with the mask on and you kind of mumbled. Okay, I'm just double checking. Again, I'm going to try to go slowly and carefully through these things so you guys can follow what it is we're doing. Haley. Sure. Okay. So 12, we have cosecant is negative root 2. I know cosecant is going to be negative wherever sine is negative. And sine is negative where the y coordinate is negative. So that's quadrants 3 and 4. And then I have to find an answer between 13 pi over 2 and 15 pi over 2. Well, I'm not really sure where that is. So we're just going to kind of count. So I know that these two are pi over 2 and 3 pi over 2. So if I go from here to here, that's 1 pi. If I go from here to here, that's another pi. So that makes that now 5 pi over 2. And I go here to here, now that's 7 pi over 2. And I go back to here, that's 9 pi over 2. And then I'm 11 pi over 2. And then I'm 13 pi over 2. And then back to here would be 15 pi over 2. Haley, are you okay with that reasoning? Okay, so we're covering then quadrants 2 to quadrants 3 is what we did there. And I find it easiest to just kind of draw a picture like that. So I'm looking for quadrant 3. Okay. Now I remember that cosecant is r over y, because it's the reciprocal of sine, which is y over r. So that would be equivalent to looking for sine of -1 over root 2. But I know that's not going to be on my unit circle because we like to rationalize our denominators. So I'm looking for that value there. So if I go to my unit circle and I look in quadrant 3, I see that it happens at 5 pi over 4. So that's going to be my base answer. The problem is that that is not satisfying this part, right? But that's the right position. So all I have to do is find an angle that's coterminal to that does fall inside of that interval. So if I add 2 pi, that's the same as adding 8/4. So that's going to give me 13 pi over 4, which is halfway there, right? Our basement is 13 pi over 2. So we'll add another 8/4. So that's going to be 21 pi over 4. Just to make it a little bit easier, this is, we make a common denominator. Since this is coming out in fourths, it's probably useful to look at that one in fourths, right? Anyways, then we'll add another 2 pi, or another 8/4. So that's 29 pi over 4, and that's the one that I need. Does that feel okay, Haley? Yeah. You're welcome. So again, not always when we go to the unit circle are we getting the angle that we need, but we're always getting an angle that's coterminal to the one we need. The last step then is just to make sure that it does indeed fall inside the interval that you want. If that interval is something that's smaller than 2 pi, it will be automatically, but if it's bigger than 2 pi like this one was, you might have to do some coterminaling. Gracie? Sure. Okay. So sine is negative in quadrants 3 and 4. I think we did that just a minute ago. Cosine is positive in quadrants 1 and 4. So I'm looking in quadrant 4. And I'm just looking for the place in quadrant 4 where the x-coordinate is 1/2 and the y-coordinate is negative root 3 over 2. Because cosine is x over r and sine is y over r. So I just need to do that. So if I go to my unit circle in quadrant 4, I need that spot there, 5 pi over 3. Is that okay? Sure. Okay. So far, so good. Jason. Sure. Okay. So secant is going to be negative the same place where cosine would be negative because they're reciprocals of one another. So cosine is negative where the x-coordinate is negative. That's quadrants 2 and 3. And then pi to 2 pi is quadrants 3 and quadrants 4. So we're going to be working or looking in quadrant 3 for our answer. And I know that cosine is going to be like the reciprocal of secant. But that's not going to be what's on my unit circle. that'll be like rationalized or whatever. So I'm just going to now go to my unit circle and look for the place in the third quadrant where cosine is negative root 2 over 2, which is 5 pi over 4. And that's it. Is that okay, Jason? Mm-hmm. Let's move on and take some questions from worksheet 2. Kristen? Sure. Mm-hmm. Okay. So I'm going to kind of start this the same way. So I know that theta is equal to sine inverse of whatever is the same thing as sine theta is equal to 0.11. And I know sine is positive in the first and second quadrants. That's wherever the y-coordinate is positive. And then if I think about the interval from pi over 2 to 3 pi over 2, that's covering quadrants 2 and quadrants 3. So my answer that I need is in quadrant 2. So far, so good? Okay. So now I'm going to draw a picture. So here's my angle that I'm looking for. That's the theta that I want, right? Now, to find that theta, what I'm going to do is I'm going to relate it to this angle here that I'm going to refer to as phi. That's just another variable name. It's another Greek letter. Don't let it confuse you. You can call it whatever you want, but I didn't want to use x or y's because those are already we're using as coordinates and it gets confusing. So how is theta related to phi here? Well, I know to the horizontal is pi. So theta is pi minus that phi. Right? Is everybody okay with that reasoning? So to do this, all I need to do is figure out phi. Now notice phi is not an angle of rotation, right? It's just an angle measure. So the way to cut is I'm just going to do sine inverse of the absolute value of 0.11. So I'm just going to use the absolute value to find phi of whatever it is that we're working on. Whether it's tangent or cosine or whatever, we're just going to take the absolute value of whatever's inside. And that'll give us our value for phi. So I'll go to my calculator to retrieve this value. If my calculator wants to open. There it goes. Now the absolute value of 0.11 is just 0.11, so I'm just going to not worry about the absolute value typing in. Tracy? That's the absolute value of 0.11. Right, so those are verticals. So that's 0.11. And then if I do pi minus that answer, I get 3.03. We'll do that. Make it a little bit easier to tell. And we can do all of these kind of in that same fashion. Should we try another one? Victoria, you emailed me about questions on this sheet, didn't you?
Yeah,
is there one? Okay. Is there another one you want to look at? Okay. Is that okay with you guys? Okay. So we'll do the same thing. Cosine theta equals 0.56. And I know cosine is positive in the first quadrant and the fourth quadrant. And then 2 pi to 3 pi, so this is 0, that's 1 pi. This is 2 pi, and then that's also 3 pi over there. So we're covering quadrants 1 and 2 in that respect. Is everybody okay there? And obviously the one that we want is the quadrant 1. So now I'm going to draw my picture. I know my angle that I'm drawing is in quadrant 1. But it's actually going to be going around like this. Since my answer needs to be between 2 pi and 3 pi, I need more than one full rotation around before I get to my angle. So again, to find that angle, I'm going to be using this angle, phi. So this spot is 2 pi. So I'm passing 2 pi and going phi more. And I know that phi is just going to be cosine inverse of the absolute value of cosine inverse of the absolute value of 0.56. So do 2 pi plus cosine inverse 0.56. And that'll give me 7.26. Gracie? So that my answer should be between 2 pi and 3 pi. So going here to the first time wasn't, I mean, it was less than 2 pi. So I kept going. There's 2 pi. And then I got to my answer. So it's bigger than 2 pi on that rotation. You know what I mean? So I just, while I'm writing my answer, I have to keep going around until I count my interval until I, oh, okay, now I've run into my answer that I'm looking for in the interval, or the angle that I'm looking for in the interval that's just indicated. If that makes sense. Okay. Josh, I think you emailed me about this assignment also, right? Was there one you want to look at? Okay.
My only question is, how do you know which angle is
the phi?
Yeah.
It's always the one with respect to the x-axis. So like here, I'm always drawing phi back to the x-axis.
Okay. Thank you.
Yeah, you're welcome. That's a good question. Jason? Yeah, no problem. So we'll start by turning this into tan theta equals negative 5.95. Tangent is negative whenever one of x or y is negative. So that is in quadrants 2 and quadrants 4. 4 pi to 5 pi, well, this is 0 pi. That's 1 pi, 2 pi, 3 pi, 4 pi, and then over here it is 5 pi. So this is quadrants 1 and 2. So the angle that we're looking at is somewhere over here in quadrant 2. So to get there, I go here, but I'm not even past 2 pi yet, so that's not soon enough. So that's 2 pi. That's between 2 pi and 3 pi, that's too soon. There we go. So I'm past 4 pi and not yet to 5 pi. So I had to go spin around twice, right? Okay. So again, this little spot in here is my phi. So here theta is going to equal 5 pi, but I'm not quite there, so I have to subtract that phi back off. And in this case, phi is going to be tangent inverse of the absolute value of negative 5.95. And I'm just going to type in positive 5.95 rather than the absolute value symbol because that's too many buttons for something that I can do in my head. You know what I mean? So when I do 5 pi minus that phi, I get 1430. Does that feel okay, Jason? Do you want to do one more from this sheet before we move on to 4? Kristen? 10? Haley, is that okay with you?
Yeah.
Okay. I know you had your hand up also. That's not that we need to check with you before we answer questions, but I just wanted to make sure we pick something that both of us are interested in. Okay. So let's do that. So this is the same thing as sine theta equals negative 0.44. And I remember that sine is negative in quadrants 3 and quadrants 4. And then to figure out where that angle is, so negative pi over 2 is here, and negative 3 pi over 2 is up here, because remember we're going counterclockwise, right, with the negatives? So this is negative 5 pi over 2 down here, and then we continue going this way to get to negative 7 pi over 2. So that's quadrants 3 and quadrants 2. So the angle that we're looking for is in quadrant 3. Okay with that? Okay. So let's draw our angle now. So this is too soon, right? Because we're not even to negative 3 pi over 2 yet. So we keep going. And that's now passing 5 pi over 2. So that's good, and not yet to 7 pi over 2, so that's our location. Now, this was negative pi over here, and then negative 2 pi, and then here's negative 3 pi that we haven't quite gotten to. Agreed with that? So we'll call this spot here our phi. And our relationship here is we should be negative 3 pi over 2. And this is where it gets a little bit tricky here because we're going the opposite direction. So like instead of adding, or instead of subtracting here like we would normally, we have to add because we're going the opposite direction. So this is really negative 3 pi over 2 plus phi, because we should be at a bigger number, right? As we continue going forward, the numbers are getting smaller, so it's like the opposite rule about adding and subtracting, which is a little bit weird. But if you think about it using common sense, it's like, oh, of course it would have to be the opposite. And phi is just going to be sine inverse of the absolute value of negative 0.44. Yeah. Make those big. Okay. So I have negative 3 pi plus sine inverse of 0.44. So that's negative, well, really, I'll call that 9.0, I guess, if I round to to 2 decimal places, like the directions it asked. And just as a check on this, because sometimes like the signs get kind of weird when we're doing the negative ones, you can always check to make sure that it's in the interval. So if I do sine of that value that I just found, I should get negative 0.44, which I got pretty close to. Make sure I'm in the right mode here. There's I am. Okay. So that's pretty close. Why did that? Oh, my goodness. Are you about to yell at me because I didn't do sine inverse? You should be, because I typed just sine. I guess I missed the button there. I was like, why didn't that work out exactly right? That would be the reason. That's better. Negative 8.97. That's better. And now if I do sine, excuse me, of that value, you see I get exactly negative 0.44, so that's a good check. So I found the right angle. The only question is it in the right position? So if I take a look at negative 5 pi over 2, this is all just checking, right? That's negative 5 pi over 2, so it's smaller than that. That's good. And then negative 7 pi over 2. And it's bigger than that one, so I'm quite confident I found the correct answer here, right? And you could do that for any of these, that kind of a check. That's always applicable and available to us. I chose to do it here because with going the opposite direction, I switched from subtracting to adding. And maybe that wasn't totally intuitive and just wanted to make sure that I had the correct answer there, but I think I do. Gracie? Mm-hmm. Yeah, so it's negative 2 pi.
And then also, how did you get 15?
Yes. So that's just the second trip around. So like the first trip, we got to negative pi. We started at 0, got to negative pi, and then we got to negative 2 pi, and then negative 3 pi as we kept going. Is that okay? What do you guys think on this sheet? Does this feel a bit better?
Yeah.
Okay. You guys ready to talk about 4 for a minute? I'll take your silence as yes. That sounds nice. Okay. And I think, Victoria, you asked me about worksheet 4 also, right?
Oh, I figured it out.
You figured it out?
Yeah.
Okay. Does anybody have a place they'd want to start here in worksheet 4? Gracie? Sure. So I'm going to start with the inside piece, that cosecant inverse of x is the same thing as cosecant theta is equal to x. And I remember that cosecant is hypotenuse over opposite. So I'm going to think about x is x over 1. So x is my hypotenuse and 1 is my opposite. Is that okay? So I'm going to draw a right triangle. I'm going to name one of the angles theta. And relative to theta then, the hypotenuse is x and the opposite is 1. So if I use the Pythagorean theorem, I have I can find this other side. Let's call that just a or something, I guess, for the sake of argument. So I can say x squared is equal to 1 squared plus a squared, or the square root of x squared minus 1 is equal to a. Okay with that? So now I have this angle. I know what angle theta looks like. So this just becomes then cosine of theta. So theta, or cosine, is adjacent which is the square root of x squared minus 1 over hypotenuse, which is x. And there's my answer. Does that feel okay, Elizabeth? So I use the inside part to build a right triangle, and then I use the outside part to evaluate, or I use the right triangle part then to evaluate the outside. And I do it kind of that same way every single time. So the inside part creates a right triangle, and then using that right triangle, I evaluate the outside. Does that feel okay? Jason? Sure. So this is the same thing as cotangent theta is equal to x. And I remember that cotangent is the reciprocal of tangent, so that would be, it means adjacent over opposite. And I'll just, since it's a fraction, I'll turn that x into x over 1. I'll draw a right triangle. I'll name it theta. So the adjacent side of theta is x, and the opposite side is 1. And then using the Pythagorean Theorem, I can see that this side is the square root of x squared plus 1. And then I remember then that secant theta is hypotenuse over adjacent. So that's going to be x, or square root of x squared plus 1 over x. And that's the answer on it. You're welcome. You guys feel better about these sheets? You ready for me to leave you alone so you can finish up on things that you need to? Josh? Yeah. Number 7, where the intervals are negative. The same way I kind of did number 10, where the intervals were negative. So I know sine is negative in quadrants 3 and quadrants 4. And then negative pi over 2 is here. Negative pi. And then negative 3 pi over 2 is up here. So this is it dealing with quadrants 3 and quadrants 2. So the answer I want is in quadrant 3. So there's my angle theta. And this is my phi. Okay with that so far, Josh? Okay. So here I'm going to have negative pi, but I need to be, because going to the left, if continuing to rotate around, the values are getting smaller. So I really want negative pi plus phi there, which is a little counterintuitive until you remember that, like, okay, everything is getting smaller as I go in that rotation. So adding, when the intervals are negative is equivalent to subtracting when the intervals are positive, which is easy to forget, but you have to you just slow down and be careful about it. And I have a devil of a time sometimes slowing down. Okay. So then I just go to my calculator. So I'll do negative pi plus sine inverse of the absolute value, 0.56. And that comes out to negative 255. Okay with that?
Yeah.
Yeah, no problem. Okay, so I'm going to stop here and let you guys kind of finish things up if you might need to.